All right, so today we're going to be talking about how to solve equations that have variables on both sides. Previously, we were working with problems that look like this. 2x plus 4 is equal to 8, right? We might have seen something that looks like y plus 5 is equal to 7. But now we're going to be talking about when we have variables on both sides of the equal signs. In both of these examples, our variable is only on the left-hand side of that equal sign. There's no term that has a variable on the right-hand side. Today, we're going to be talking about what happens when we have variables on both sides of the equal sign. So to solve equations with variables on both sides, you have to collect variables to one side. So let's put that into an actual example. So we have 4x plus 15 is equal to 7x. Notice I have a variable on the left-hand side and a term with a variable on the right-hand side. Normally, or previously I should say, we've seen terms that have a variable on either the left or either the right, never on both. So our job is to be able to get to a position that will allow us to move that variable or the term with the variable to one side of the equal sign. Here is the biggest tip that I can give you, and it works about 90% of the time. Not always, but especially with our more challenging problems, it's going to pay dividends. We want to move our variable or the term with the variable, that way it ends up being positive. For this example, I'm pretty much forced to bring this 4x over to the 7x because I only have one term on the right-hand side. But generally speaking, if possible, we want to have that variable be positive. That way, when we get down to solving these more difficult problems, we're going to have a positive coefficient, meaning that we're dividing by a positive and thus reducing the chance of having some kind of error. So, just like I said, we want to move this 4x over to the 7x. Well, to do that, we want to subtract 4x. Just like if it was a constant where it only had the number and didn't have variable, it was just a number. We want this to turn into 0. 4x minus 4x does indeed go to 0. So now we're left with 15 is equal to 7x minus 4x. Those are like terms, thus we get 3x. And now we have a one-step equation. Well, I want to get that x all by itself. I have 3 of them, so I have to divide by both sides by 3. Thus we get 5 is going to be equal to x. You technically can also have x is equal to 5. That is the same thing. 6 to 1, half a dozen the other. It's like saying 2 plus 2 is 4, and 4 is equal to 2 plus 2, right? So again, we want to collect those variables on one side of our equal sign. Let's try out another problem. Let's say we have 15 minus 2x is equal to negative 7x. I notice that, again, I only have one term on the right-hand side, and I have 2 terms on the left-hand side. Well, this pretty much forces me to send this negative 2x over to the other side. So let's do that. Let's bring this negative 2x over to the other side. But to do that, I have to perform some inverse operations. Well, I have to add 2x to both sides. Again, this ends up turning into 0, which is what we want to happen. We get 15 is equal to negative 7x plus 2x, which is going to yield negative 5x. We want to divide both sides by negative 5, just like we would any normal one-step equation. So now we have that negative 3 is equal to x. Again, if you had it as x is equal to negative 3, that's fine as well. Right, so all we're doing is we want to pick a side that our variable is going to be on. In these two examples, we were pretty much forced to go to the other side of the equal sign because we only had one term. But sometimes when we have multiple terms on both sides, we're going to have a different situation. So let's try one out on your own. Please solve this problem on your own, and then when you're done, please continue the video. That way we can compare our answers. All right, so if you're listening to my voice, that means that you have attempted this problem and you are ready to see the solution and how we get to that solution. Well, I see I have one term on the left-hand side. I have two terms on the right-hand side. I see variables on both sides of the equation, so I need to choose which side of the equation I want to get my variable on. Well, I'm pretty much forced to send this 2x over to the other side. To do that, I have to subtract 2x on both sides, because this now goes to 0. Negative 3x minus 2x is going to be negative 5x is equal to 19. And now I have a one-step equation. I divide both sides by negative 5. So we get that x is equal to negative 19 over 5. And we can leave it as an improper fraction. That's totally fine. We can't simplify 19 and 5. They're actually both prime. So we can leave this as our final answer. Great job so far. But what if we have a problem that looks like this? It does look a little bit more challenging, but we can definitely work with it. Let's talk about what we notice. Well, I notice I have variables on both sides. I see I have a set of parentheses. I have a fraction on the outside of those parentheses, which tells me I might need to use the distributive property here. And I have constants on both sides now. I have multiple terms on each side of the equation. Well, let's just look at the right-hand side first. Let's look here. 3x minus 5. Can I simplify that at all, or is that fully simplified? It's fully simplified, so it's going to stay exactly how it is. I can't do 3x minus 5. Those are not like terms. We look inside our parentheses. 8x minus 4. Are those like terms? Can I combine them together? No, I can't. So I can't operate within my parentheses. I notice I don't have any exponents, but I do see some multiplication. So I'm going to distribute this 1/2 into the set of parentheses. So I need to simplify both sides first. Well, 1/2 of 8x is 4x. 1/2 of negative 4 is negative 2. That's going to be equal now to 3x minus 5. And this is where I started bringing up before. We want to try to get our variable and that coefficient of the variable to be positive. Well, if I'm comparing 4 and 3, which number is bigger, 4 or 3? Well, 4 is. So that means I'm going to want to bring the 3x over to the other side. And to do that, I subtract 3x. This goes to 0, which is perfect. 4x minus 3x is x. I have x minus 2 is equal to negative 5. Notice that that sign stays with that 5. So now I have x minus 2 is equal to negative 5, and now we just solve it because this is a one-step equation. We add 2 to both sides. This goes to 0. So we have that x is going to be equal to negative 5 plus 2, which is negative 3. Beautiful. Beautiful. All right, let's do one more. Last problem for right now. We have 2.5y plus 6 is equal to 4.5y minus 1. I again need to see, do I have anything to do to simplify either side first? Well, I have 2.5y plus 6. Those aren't like terms. I have 4.5y minus 1. Those are not like terms. So I need to move my variables over to one side. My biggest tip, again, is move your variables first when you have multiple terms on one side. So move your variables first. Trust me, it's going to pay off in the long run. So I'm comparing 2.5 and 4.5. 2.5 and 4.5. Which number is bigger? Well, 4.5 is. So I'm going to subtract 2.5y and move that to the other side. I know it's decimals, but it's okay because it's still, just operations, just how we've been doing. Okay, so 2.5y minus 2.5y goes to 0, so we're left with 6. Now we have 4.5y minus 2.5y, which is 2y, and we drop down that minus 1. So now we want to get our constants to the other side of the equal sign. This goes to 0. 6 plus 1 is 7. Is equal to 2y. Or we brought our variables to the right, which means we want to bring our constants to the left. So now we solve this by dividing by 2. So we get 7 halves is equal to y. Great job, folks. If you have any questions, please feel free to reach out. Again, in summary, we want to get your variables on one side of the equal sign. If given the choice, 9 times out of 10, you want to have a positive coefficient for your variable, so move your variable to where it's going to be positive. Move that lesser one to the greater one, and then you want to move your variables first. And that's how we solve equations that have variables on both sides.